Exact values of trigonometric functions of special angles. Examples. Find exact values of trigonometric functions for below special angles. So let's see tan 120 degrees. If you try to punch in tan 120 degrees in calculator, you will get a decimal answer, which is not acceptable because it says find exact values. So this is the procedure we follow. First thing is we sketch. Where is this tan 120 degrees? We know this is 0 degrees, this is 90 degrees, this is 180 degrees. So 120 degrees will be somewhere here. And that is from in standard position, so from 0 degrees onwards. If this is 120 degrees, we need to find out how much is this remaining. So we say 180 subtract 120 giving us 60 degrees. So this is 60 degrees. Now this is in quadrant 2. We know it's in quadrant 2. And using all S, T, C, quadrant 2. So tan theta will be negative. And now reference angle as we saw is 60 degrees. So we know alpha is 60 degrees. So we can find out value of tan 60. And that will depend on those special triangles we saw earlier. So the one with 60, 30, 90. So let's say this is 60 degrees. This will be root 3. This is 30 degrees. This will be 1 and this will be 2. So tan 60 opposite over adjacent will be square root of 3. So in our case then tan 120 degrees will have same value of tan 60 because it's in the second quadrant, tan negative, it will be just a negative root 3. Okay. Let's try another one. If you want to solve for sine 240 degrees, we sketch where 240 is. We know this is 180, this is 270. So 240 should be somewhere here. So from beginning till here is 240. We want to find out alpha here, this one. So it will be basically 240 minus 180. So 60 degrees here. So this is 60 degrees. So alpha will be 60 degrees. It is in quadrant 3. In quadrant 3, sine is negative. So we will say quadrant 3, sine theta negative. Because sine theta is negative there and value of sine 60 from this triangle right here, opposite over hypotenuse, so that's root 3 over 2. Sine 240 will be same number, just negative sign because it's in the third quadrant, sine is negative there. Okay, let's look at one more. Cos 225 degrees. Cos 225 degrees. So if you were to look here, this is 180, this is 270, so it will be somewhere here. From here to here is 225. We want to find out this one. So we can say 225 minus 180, which will be 45 degrees. One of the special triangles, only 3 possibilities. 45, 30, 60. So if it is ending in 5, we don't even need to calculate this. We know it's automatically 45 degrees. Okay. So alpha here will be 45 degrees, quadrant 3, and cos theta will be negative there. So then we can say cos 45, again we need a special triangle with 45, 45, 90 degree. So let's say this is 45 degrees, this is 45 degrees, it's 1, 1, root 2. So sine 45, cos 45 both are 1 over root 2. Now we have cos 45, so then cos 225 degrees will be same number. Because it's negative in the third quadrant, it will be just a negative sign. Okay, let's see some more. Let's say we have cosecant 135 degrees. We know cosecant 135 degree is same as 1 over sine 135 degrees. So we need to find sine 135 degrees first. So let's sketch. Where is this? Sine 135 degrees will be somewhere here. Where we go from here to here is 135 because this is 90, this is 180. This will be alpha. In our case then it will be 180 minus 135, which will be 45 degrees. Because this is 45 degrees, alpha will be 45. And all S, T, C. We are in this quadrant, sine is positive there. So we will say quadrant 2, sine theta positive. So then cosecant theta will also be positive. Now value of sine 45, again using one of those special triangles, let's quickly sketch it here. This is 45 degrees. This is 1, this is 1, this is root 2, this is also 45. Sine 45, cos 45, both are 1 over root 2. So in our case then, sine 135, in the second quadrant, it will be still positive. So it will be still 1 over root 2. And finally, cosecant 135 is reciprocal of that. So it will be just root 2. Okay. Similar to previous one, this one we know it will be similar as 1 over cos 330 degrees. So that's what we will need to find first. So let's quickly sketch this again. 330, we know this is 270, this is 360. So 330 should be somewhere here. So from here to here is 330. One complete circle is 360. So remaining has to be 30 degrees. So or you can do some calculation. It will be 360 minus 330, which will be 30 degrees. So alpha is 30 degrees and it is in quadrant 4. In quadrant 4, cos is positive using CAST. C is positive in here. So we will say cos theta positive. So automatically secant theta in that quadrant will be positive. Now value of cos 30, we can use the other triangle where let's say this is 30 degrees. Opposite of that will be 1. This is 90, 60, root 3 and 2. So in this case then cos 30 is adjacent over hypotenuse. So it's root 3 over 2. That is root 3 over 2. And then because we are in the fourth quadrant, cos 330 will be still same, no negative. And lastly then secant 330 we can say is 2 over root 3. And some of us rationalize this, but it's okay to leave it like this. If you were to rationalize this, it will end up being 2 root 3 over 3. Lastly, if you were to find cot 240, similar to previous ones, we will first sketch this. 240 will be somewhere here because this is 180, this is 270. So here to here is 240. So this one right here will be 240 subtract 180. So in our case, it will be 60 degrees. So this is 60. Alpha is in the third quadrant, which is 60 degrees in quadrant 3. In quadrant 3, tan theta is positive. So then cot theta will also be positive. Now we need to find out what will be the value of tan 60 degrees. So we write tan 60 equals, so tan 60 is opposite over adjacent. So in our case root 3 over 1. If you like, we can leave it as this or fraction because we need to flip it later. So now value of tan 240 degrees, because it's in the positive quadrant, still remains same. Then cot 240 is reciprocal of tan or flipped version, which is this. Or if you were to rationalize it, it will become like this. So it's root 3 over 3.